All right, so good evening, everyone. Welcome to today's online class. We are in week 3 of our math tutorial, and today we're going to be looking at quadratic equations and basically the theory of quadratic equations, how to go about solving them, and all the necessary intricacies that have to do with understanding how they work. So the objectives for this lesson to understand the general form and types of quadratic equations, to learn the methods of solving quadratic equations, explore the concept of discriminants and nature of roots, and then use the relationship between roots and coefficients for analysis and reconstruction. So without further ado, let us get right into it. So first of all, what do we mean by quadratic equations? So before I give an explanation or a definition, I want to take us back to the foundations, to the basics. So when we used to do algebra back then in secondary school, we would always work with simple equations. For example, 2x plus 3 is equal to 10. And you will be asked to find x, to find the value of x. Now, that would have been a very simple question, right? You collect the like terms, so all the constant terms come to one side and all the variable terms stay on one side, and then you solve for x. That's pretty straightforward. And then even when we had things like simultaneous equations, they were all straightforward things. So those kind of questions were linear equations. Now, linear in the sense that the highest power of any of the variables you had was always one. And another reason why this is the case is that if you get to, so for example, 2x plus whatever, 2x plus y equal to 5 or whatever, if you were to plot a graph of that equation, you are going to get a straight line graph, right? So hence the name linear, because it's moving linearly, it's moving in a straight path. So that is a linear equation because the highest power of the variable you had was 1. Now, when we come on to talk about quadratic equations, we are going a step higher. So now we have a power of 2 as the highest variable. And there also, we can go higher than that, right? So we have cubic equations where the highest power you have is 3. And then, of course, we have higher order polynomials as well. So, but then we're going to be looking at quadratic equations. So the quadratic equation is of form ax squared plus bx plus c. Of course, like I've just said, the highest power of the variable, so a, b, and c are constants, right? And the highest power of the variable, x, is 2. So that is simply what makes an equation quadratic, that you have the highest power of the variable as 2. And of course, you can also have other variables existing, but their powers should not be higher than 2. And of course, where a is not equal to 0, because if a was 0, then this term will disappear and the highest power will be 1, and then this will not be a linear equation, bx plus c. So that is what a quadratic equation is. Now, of course, why it's important to know how it works and how to solve is that more often than not, when you're working with higher processes or setups or higher analysis of systems, you may not always arrive at equations that are linear, right? More higher processes will resolve to higher order polynomials. So you start seeing powers of 2, powers of 3. So these things do come up, and then you need to know how to solve them as well in order to also find your x, which you're always looking for. So when it comes to solving quadratic equations, we have 3 methods. So there's the method of factorization, there's the method of completing the square, and there is the quadratic formula, aka the almighty formula. Some of you may have already heard of that nickname before. So when looking at solving quadratic equations, of course, I would say the easiest method is the factorization method. However, not all quadratic equations can be solved using the factorization method. Of course, these are things that you would see for yourself now as I go further to explain. But then it's the easiest method. So if you can use it, if this equation can be solved using it, you should most likely just use the factorization method. So the other 2 methods can be used for any form of quadratic equation, but they obviously involve a lot more, complexities than the factorization method. And So yeah, we're going to be looking at all three of them, starting with the factorization method. So here's a quick example illustrating what the factorization method is and how it works. So we have a quadratic equation here as x squared minus 5x plus 6 equals 0. Now, of course, this is quadratic because we have x to the power of 2 as the highest power in our equation. So you can already tell this is a quadratic equation. Now, how do we go about solving this? Using the factorization method. So remember that for our general form of the quadratic equations, we have ax squared plus bx plus c. So this has a variable, this has a variable, and this is a constant. Fantastic. So when you want to do the factorization method, you begin by, first of all, multiplying the constant a, and the constant c, right? So here, our constant a is 1 because the coefficient of x squared is 1, and the constant c is 6 because that is the term that does not have any x attached to it. So what you do is to first of all multiply your a and your c. So in this case now, in this particular example, that will be 1 times 6, right? And 1 times 6 is going to give us 6. Now, what you are going to try to figure out is in that product that you have, so in this case now it is 6, you now have to figure out what two numbers can I multiply to give me 6. So basically 2 factors of 6, right? What two numbers can I multiply to give me 6? And then when I add those two numbers, they will give me my b, that's the coefficient of x in the question. And the coefficient of x in this question is -5. Now, if you go through all the factors of 6, you have 1, 2, 3, and 6, right? Now you have to find two of those factors that when you multiply, they will give you your product of a and c, which is 6. And when you add them, they will give you the coefficient of b, which is -5. Now, here you now start to see why it is not in all cases that the factorization method can work. Because it is very possible that when you have this product and you go through all the factors of the product, there are no two numbers that satisfy this your condition. You will not be able to get any two factors that their sum is b, is coefficient b, and the product is a times c. So you now realize that, oh, this method cannot work. First of all, let's look at the case where it works, which is this particular one. So if I look at the factors of 6, I see that -2, I see, okay, so for example, 1 times 6, right? Those two numbers, well, they give me 6. But 1 plus 6 does not give me -5. 1 plus 6 gives me 7. If I change it, -1 and -6, multiplying that gives me 6, right? But -1 plus -6 gives me -7, which is not what I want. So 2 and 3, two other factors that give me 6. 2 times 3 gives me 6. 2 plus 3 gives me 5. But what I actually have is not 5. What I have is -5. So it's very important to note that when you're dealing with the coefficient, you're also considering the sign. So the coefficient of x here is not 5, but -5. And so 2 and 3 do not actually satisfy my condition. What does satisfy my condition in this case is -2 and -3. Because -2 times -3 gives me 6, which is my product. And -2 plus -3 gives me -5, which is the coefficient b. So I have found my two numbers and I have what I can use to proceed. So having found those two numbers, to keep that at the back of your mind, having found those two numbers, the next thing you do now is simple. So you have this as the original equations. Our two numbers are -2 and -3. And so you replace the middle term, so the term that has x as its coefficient, you replace it with those two numbers that you just found. So we got -2 and -3. So we erase this and replace it with -2x. Okay, that's -2x, and then the second number was -3x, right? And replace it with -3x. Now if you look at this, we haven't actually changed anything, right? Because -2 minus 3 is also -5. So this equation and this equation is exactly the same thing, but we have specifically chosen to replace -5 with these two numbers, and you will see why. So now that we have done this, we now do what we call a grouping. So we take, let's copy that. So we take these two. So the order in which you place this is not very relevant actually, because in the end, your result will still be the same, right? So you could have written -3 first, or you could have written -2 first. It doesn't really matter. Now you group. So now you have 4 terms. You group these two together, and you group these two together. And now the next step you do is now where the name for what we are doing, the method we're using comes from. You factorize. So you bring out the like terms. So you factorize this first bracket. Of course, what is common to both of them? So what factorization simply means bringing out what is a factor of both of them. So this is x squared and this is x, right? So what is the factor of both of these? The factor is x. So let's copy this. Factor is x. So we can write as our next line, factoring out x. So this becomes x minus 2. So if you open this bracket, you have what you have here, right? And now we have 3x and we have 6. What is common to both of them is 3, as you can see. So you factor out 3, this becomes x, and this becomes, so we have actually a factor now -3. So this becomes x, and this becomes -2. Because if you open this bracket with -3, you have -3x plus 6, which is what we had here originally. Fantastic. So I think I'll just put the minus inside, so that becomes clear. Fantastic. So here is what you have. Here is what you have. So now, if you notice, what we have in the bracket over here is exactly what we have in the bracket over here, right? And so you can simply just take one of that and write x minus 2, and then we take what we have left, which is x minus 3, right? And so remember that this is equal to 0. So now that we have factorized, if you are putting it into a bracket, what this simply means is that x minus 2 is equal to 0, and or x minus 3 is equal to 0. And so the thing with quadratic equations, unlike linear equations, is that when you solve a linear equation, you get one answer that satisfies your equation, right? Which is why it is linear. However, for a quadratic equation, you always have two answers that satisfy your quadratic equation. So, and those two answers can be the same. So we'll get to that later on how you can have different roots or same roots. But you always obtain two answers that can satisfy your equation, basically two roots. So if you were to use the proper terminology, your final answer here, which is going to be x is equal to 2 or x is equal to 3. This shows that 2 and 3 are the roots of this quadratic equation, x squared minus 5x plus 6. And of course, you can test your answer to find out whether you are right. So you can take 2 or 3 and put it here and see whether it gives you 0. So quickly, if you put 2 here now, this is 2 squared 4 minus 10, which is minus 6 plus 6 is equal to 0. So you see that by the method of factorization, we have been able to arrive at the roots of this equation. We have found the two possible values of x which satisfy this quadratic equation. So yeah, basically this is how the factorization method works. Now, like I said earlier, not all equations will be easily resolved with this method, right? So looking at the process that the nuances involved, you see that you might have some cases where you can't get two numbers that satisfy this condition of like we had here, we replaced -5 minus 2 and 3 because the sum was the middle term, and then the product was the product of A and C. So having known that, we now have to look at and understand other methods of solving quadratic equations, especially when we come across cases where factorization simply will not work. And so we go into the completing the square method, right? So as the name implies, completing the square. So we are going to be looking at something very different to what we did earlier. And outlined here are a bunch of steps which you should follow in order to be able to use this method. So first of all, we start with the general form of the quadratic equation as always, which is ax squared plus bx plus c. And this is the quadratic equation we are given. Now, how do we solve this? So first things first, you write the equation in the form such that c is on the right side. Right? Step 2, if a is not equal to 1, divide the complete equation by a such that the coefficient of x squared will be 1. So in using the completing the square method, it is very important that the coefficient of x squared is 1. Now, in the previous example we did, it was already 1. And so if you are going to use, so we're going to use completing the square to do this, and then we'll just look at another example so that it becomes clear that both methods give the same answer. If we're going to do this with completing the square method, we would not really, we will skip this step because here the coefficient of x squared in this equation is already 1. You will be given equations where they will not be, it will not be 1, right? It might be something else, it might have a constant coefficient of higher than 1. So for completing the square, it's necessary that the coefficient of x squared always be 1. So if it's not 1, then you have to divide your whole equation by that coefficient so that x squared, the coefficient of x squared becomes 1. Step 3, add the square of half of the coefficient of the term x on both sides. So basically what this means is that the coefficient of the term x, which is b, you divide it by 2, and then you square it, and then you add it to the left-hand side, and then you add it to the right-hand side. Now, of course, doing this does not make any difference because if you're doing the same thing to the left-hand side as you're doing to the right-hand side, then the equation basically remains the same. Then step 4 is to factorize the left-hand side of the equation as a square of the binomial term and take the square root of both sides and solve for x, find the root. So a lot of this is not going to make sense until we do an example. So let's just get right into it. So as I do the examples, we'll come back to the steps and you understand what they mean and how they actually apply in the context of solving these equations. All right. So an example, to solve x squared plus 4x plus 1. So quickly, before I go on, I would just want to show you how and why factorization cannot work here. So if we're to do the product of a and c, so a is 1 here and c is 1. So 1 times 1 is 1. So now I need two factors of 1, that the product is 1 and the sum is going to give me 4, right? Now, the only factor of 1 actually is 1. So if I say 1 times 1 is 1, 1 plus 1 does not give me 4, 1 plus 1 gives me 2. So there are no two factors of 1 that satisfy this condition of giving me 4 when I add them together. Simply does not exist. And so the method of factorization which we have learned will not work here. But we know that there is a solution to this quadratic equation. So now we are going to use the method of completing the square to figure it out. So step 1 is skipped, like I said here, because already the coefficient of x squared is 1. So there is no need to, divide through or anything. It's already 1. And so we go on to the next step, which is to move the constant term to the right-hand side of the equation. So we have x squared plus 4x plus 1 equal to 0. And then we take 1 over to the other side and it becomes minus 1. Now, of course, here we have the important step to note that is step 4, I think, here. So step 3, add the square of half of the coefficient of 10 minus x on both sides. Now, the coefficient of x in this question is 4. And so the next step tells us that we should add half, the square of half of that. So basically 4 over 2 all squared, and then we add that to both sides, right? So 4 over 2 is 2, 2 squared is 4. So you add 4 here and then add 4 here. Like I said, this doesn't actually change the equation because if this 4 comes over to this side, cancels out with this 4, and then we have the original thing we had here, right? So we simply do this in order to be able to factorize the left-hand side, and we'll see that in just a bit. Because when you do
No,
this,
please, I don't understand. Can you repeat the last step?
Okay, fine. So I think I'll just write it out so that it becomes clear. You mean the part about taking the half of the coefficient of x and adding to both
Yes,
sides, right?
yes, yes, yes,
Okay, fine.
yes.
So let me use the original example where we did the factorization. So from here now, what is the coefficient of b here? Let's say we are doing this one with completing the square. What is the coefficient of b in this one? S squared minus 5x plus 6. Whitney, are you still with me?
I don't understand.
Okay. So you remember when we talked about the general form of the quadratic equation, ax squared plus
Yes,
bx plus c is equal to
yes,
0. So
yes.
in this general form, what is the coefficient of x squared?
A,
Fine. Coefficient of x is what?
D.
The coefficient of course, the other term is a constant term. Right. So like the steps have illustrated, when you're doing the completing the square method, you take the coefficient of x, right? You
Okay.
divide it by 2, and then you square it, and then you add it to both sides. Now, what that
Okay.
means in this question is that, say we are using completing the square to do this other one. Okay, let me clean out this so that we get the picture. Say we are using completing the square to do this one. It means that I would look for what the coefficient of x is. And the coefficient of x in this question is minus 5.
5.
You agree, right? So minus 5,
Yes.
not just 5. So that sign is very important. You have to always consider the
Okay.
sign. So what you would do now is you have x squared minus 5x plus 6 equal to 0. The coefficient of x is minus 5. So you would now do minus 5 over 2 all squared. So it will look something like this. So, okay, this goes over to the other side. So this is minus 6, right? So you would add plus 5 over 2. So minus 5, actually, minus 5 over 2 all squared. From my superscript, right? So you add it
Yes.
this side, and then you also add it to this side,
Okay.
right?
Okay.
So this is the next step now. You take the coefficient of this of x divided by 2 and square it and add it to both sides. Now, like I said
Both
before,
sides.
the equation does not change because you're doing the same thing to the left hand side and you're doing the same thing to the right hand side. So the equation is basically the same. Now, but
Okay.
we are doing it for a reason. We are doing it so that we can be able to easily factorize the left hand side, and you will see why in just a moment. So when you now do this, so we have constant terms on the left hand side and we have constant terms on the right hand side. Now, when you do this completing the square, your left hand side always resolves to something that is very simple, because now stay with me. When you have this, you can easily write for the left hand side, it becomes x minus 5.
That's 3.
Yeah, I've corrected that. 5 over 2. So, minus 5 over 2 squared. And then this becomes, so whatever minus 6 plus 5 over 2 minus 5 over 2 squared is. Okay. Now, if you open this, if you simplify this, yeah, you would see that it will give you this. Now, but what we have done is we have factorized it, but there is an easy way out of it. Because once you've written this, the left hand side in this form, what you simply do is to take your x and to take whatever is in this inside this squared and write x minus that, then all squared. Because if you open this bracket, if you do x minus 5 over 2 all squared, which is simply the same thing as saying x minus 5 over 2 times x minus 5 over 2. Now, if you open this, if you simplify this, you would see that it will give you the same thing that you have here, right? So let me use the other example to show you what I mean. So here, the coefficient of our x was 4, right? Now, the rule says you divide the coefficient of x by 2, which is 4 over 2, right? And then you square it, which is 4. So this is x squared plus 4x plus 2 squared, right? So this resolves to x plus what was in that squared is 2. So x plus 2. Then you now square everything on the outside. Because if you open this now, if you expand this, this is saying x plus 2 times x plus 2. If you open that x plus 2 times x plus 2, you will get this x squared plus 4x plus 4 again. So we have, by adding that number to the left-hand side, we have found a way to, reduce it, to factorize it, to take this form of x plus something all squared. Now, if you open this bracket, you still get this the same thing. And this always happens when you do completing the square. So it's kind of like a shortcut. It should become intuitive. So this is the same thing as writing plus 2 squared. Let me just copy this. So plus 2 squared, right? And so what you now do when you are here is to take this x, right? Take this 2 and then square everything on the outside. Because when you open that bracket, when you resolve this, you will get back this. It always happens when you do completing the square. I don't know if it's clear to you now. So when you resolve this left-hand side, what you have on the right-hand side is are constant terms. So minus 1 plus 4 is 3. Now that you have this almost resembles a linear equation, because from here, what you now do is take the square root of both sides. And you can do that because this square is covering the whole bracket. So if you take the square root of this side, this square goes away and you're left with x plus 2. Then you take the square root of the right-hand side and you're left with plus or minus root 3, which is plus or minus 1.73. So of course, when you know that.
Why is it plus or minus?
Okay, yes, I'm about to explain that. So if you do minus 2 times minus 2, you get 4, right? If you do
Yes.
2, you also get 4. So the thing with square roots is
Yes.
that you can have a negative or a positive. It depends on which one you want to use, right? So when you do square roots, the proper way, I mean, we're not always taught this, but the proper thing is that you have two possible answers when you do a square root. Because square root of 4, I can tell you that the answer is minus 2. I can tell you that the answer is 2, and I will be correct because minus 2 times minus 2 is 4. 2 times 2 is also 4, right? So, and
Yes.
again, because of that, we will always have two answers for our quadratic equation. Because if I say, so root 3 is 1.73. If I say I want to use the positive, then our x will now be 1.73. This 2 comes over here, minus 2, and that will be minus 0.7. If I say I want to take the negative, it will be minus 1.73 minus 2, which will be minus 3.73. So again, I have two possible answers to my quadratic equation.
Hello,
So
sir.
this, okay, I'm listening.
What happens if the number on the other side had been -3, like x plus 2 squared equals -3? When I do the square root, would
Yeah.
my answer still be positive and negative?
No. So that will almost always not happen, right? So because you are adding something, it will probably always be a positive. I don't think I've seen a case where you're going to have a negative on this side, right? And then if it happens, then that cannot work because you cannot take a square root of a negative number. It's not possible. It will probably give you an
Okay.
imaginary number. And so that's a good question, because that would not be a case where even this method cannot work, and then you now have to use the quadratic formula method to solve your quadratic equation. So that's the only way
Okay.
out, using the quadratic formula method. But more often than not, if you're going to do this, then this is going to be positive, and then you would resolve your answer from there. So just so that this is clear, I want us to do this other one with the same finish this one with completing the square method. So like I said, this is going to be So you take the x and you take whatever is in this bracket. This is x minus 5/2, right? So 5/2 is 2.5. So let's just write it out so that that's easier. So x minus
0.5
2.5, right, is equal to
square
minus 6 plus, so minus
2.5.
5/2 squared is so that's 25/4. And then
Yeah.
what does that give us in decimal?
6.25, I think.
6.25. Yeah, that's correct. 6.25. So
Hello,
okay,
sir.
let's not forget our squared here.
The left. Okay.
Let's not forget our squared here. So fantastic. So now we have, so let's just copy this because we have the same thing on that line. So minus 6 plus 6.25 is going to give us 0.25.
0.25.
Yes. So 0.25. So it's positive. So now we take the square root of both sides. So if we take the square root of this squared goes away, and you're left with x minus
X
2.5.
minus 2.5.
And we take the square root of this is going to be 0.5. So now it's going to be plus or minus 0.5 actually. So let me just write it out. Or minus 0.5, because a negative can do satisfy your answer and a positive can satisfy your answer. So now, if you want to find what x is, you can either do 0.5 plus 2.5, which is going to give you 3, or minus 0.5 plus 2.5, which is going to give you 2. So you see that using this method, you still arrive at the same answer that we had when we did the factorization. And of course, this shows that either method works, but for cases where factorization cannot work, then you cannot use it, and then you have to use either one of completing the square or the quadratic formula method. So, but then I've shown you that either one of them, you still arrive at the same answer. So the trick is just to
Hello, sir.
understand. Okay, yeah, go ahead.
I just want to confirm, like if I have a question that requires me to do the completing the square, this is everything about completing the square, right?
Yes, this is everything. So of course you can solve more examples so that you just everything about it sticks. The more you do it, the easier it becomes to remember. So the part that you may probably mess up more often than not is what you have to add to both sides, right? And then from there now come to here that you have a perfect square. But pretty much everything about it is straightforward. So this is everything about completing the square.
Okay, thank you.
Yeah. So having done that, we will now go to the last method, which is the quadratic formula. So basically, it is a formula, as the name implies, for solving quadratic equations where every other possible method has failed. Now, the derivation of this formula was actually derived from using the general form ax squared plus bx squared plus c, and then you now do completing the square from here, and then I mean a lot of manipulations involved, but we will not be going into that. What matters here is for you to be able to remember and write out the formula when the need applies. So as you can
That's
see,
the question, sir.
okay, go on.
This is, I don't know if it's peculiar to me, but this is a very big challenge for me. I have a huge problem remembering formulas.
You know,
I can understand, I can apply, but remembering and knowing which formula goes to which thing is a problem.
yeah, but I mean, if you are going to be able to solve math comfortably, it's something you have to overcome because you would meet it many times. So, I mean, quadratic formula is pretty unique. Yeah, I mean, there are not two or three of it. There's only one quadratic formula. So, like I said, solve as many examples as possible with all these steps and all these methods and all these processes, because that's the way it's going to stick. You remember it more often. So the formula is not very complex. So minus b plus or minus square root of b squared minus 4ac. all over 2a. So this division is for everything, all over 2a. Now, what this simply means is that when you have the quadratic equation, b, a, and c are the coefficients that you already know, and then you just pick them and put them into the formula, and you're going to have your x. Of course, you're going to have two possible values of x as always, because you're going to take a square root and you're going to have plus or minus. So for the example we are giving here, our equation is 2x squared plus 3x minus 2 equal to 0. Now this is our formula. We need to find what our a is, what our b is, and what our c is. Right? So from this formula, we can see that our a is 2 because that's the coefficient of x squared. Our b is 3 because that's the coefficient of x, and our c is minus 2. So always pay attention to the sign. If it's a minus, then you don't just write 2. Take the minus because it's going to affect your final answer. And so you just plug it in the formula. So minus b, the formula is minus b, right? So you write the minus and then write whatever your b is. So our b is 3. So minus 3 plus or minus square root of b squared, which is 3 squared, minus 4ac. So a is 2, c is minus 2, then all over 2a. Right? So the next step is basically just simplification from here on. Minus 3 plus or minus square root of square of 3 is 9. Then 4 times 2 times minus 2 is plus 16 because minus and minus makes plus. And then all over 2 times 2, which is 4. 9 plus 16 is 25. Square root of 25 is 5. Right? So we have minus 3 plus or minus 5 over 4. So if you solve with the plus, you're going to have minus 3 plus 5, which is 2 over 4, which is 0.5. And if we solve with the minus, you're going to have minus 3 minus 5, which is minus 8 over 4, which is minus 2. And there you have your answers. So this is the quadratic formula method for solving quadratic equations. I'm not sure, but I think this can also be done with the factorization method. Minus 4. Let me see. So 2 times minus 2 is minus 4. If you do minus 4 and minus 1, yeah. So it's possible for you to also do this with the factorization method, but we use the formula to show that this can also be done with the formula. So this is one of those ones that you could have used factorization to do anyway, but then some will arise, like the one we did here. It's simply not possible to use factorization. So you apply the formula or you apply complete in the square. So yeah, using the quadratic formula, the main thing is just remember what the formula actually is. So how you do that is by repetition, right? Mastery only comes by repeated practice. So like I said, over and over again, repeatedly keep using it, solve examples as many as possible, and then you should be able to remember it and recall it and know when to use it when the case arises. Right. So and for something to do, maybe as an assignment or something, you can just try this particular question out with the other two methods. I think factorization can work here, from what I see, and then completing the square as well, and then see if you also arrive at these two answers that we have here in the using the formula method. Yeah, so those are the 3 steps for solving quadratic equations. Next, we're going to move on to representation of roots. Now, remember I said at the beginning that the difference that you have between the linear equation and the quadratic equation is that when you have a linear equation and you want to draw the graph of a linear equation, you're going to have a straight line graph, right? It's going to be a line that follows a straight path. Now, for a quadratic equation, you have a curve, a parabolic curve to be exact, because this takes the shape of a parabola. Almost all quadratic equations have this U shape. So you have this shape. So it's either it's a U shape or it's an N shape. So it can be upside down. But this is the shape of the curve that a quadratic equation takes. Now, why you have two possible answers is because this curve intersects the x-axis on 2 different places, right? And those 2 places are the values of x at those 2 points satisfy the equation. So if you were to have a cubic equation, for example, an equation that has 3 as the highest power, you will see that it will intersect the x-axis at 3 different places. And so those 3 different values of x at those positions will satisfy the equation. However, there are cases where your answer for a quadratic equation, your 2 possible answers for a quadratic equation can be the same. And there are cases where you would not even have an answer. For example, you have an imaginary number as your answer. So that was Whitney's earlier question, where what if the what you have on the right hand side was a negative number, and you're taking the square root of a negative number. And now, if you've done any higher level algebra, you would know that where we get imaginary numbers from are when you have square roots of negative numbers. So square root of -1, for example, now we now introduce the imaginary number I or J, depending on the textbook you're looking at. Some call I, some call J. And then you start to see numbers like 1 plus 3I or 1 minus J or weird things like that. Those are imaginary numbers. And so these 3 different cases or these 3 different illustrations show us when these different cases arise. So for this one now, all the examples we've done have roots that are real and unequal. So we've had 2 distinct separate answers. So this is this case, right, where the parabola, the curve, intersects the x-axis at 2 very different points. So you have an answer. And also it can be negative, and one can be negative, one can be positive, both of them can be positive, both of them can be negative, but they are on the x-axis and they are 2 different points. Now, we can also have a case where the 2 answers we obtain for our quadratic equations are exactly the same. And so you have this kind of curve where it just touches the x-axis on one point and then goes up. So, right, so the 2 roots you obtain, the 2 answers you obtain are the same. So this is what you have when you draw it, when you illustrate it. Now, the third possible case is the curve doesn't intersect the x-axis at any point. So in that case, we'll say that there are no real roots. And that's when you start to have something like the answers are imaginary numbers, right? Because the curve, as you can see, doesn't touch the x-axis on any point. So you can't pick any real number on this line and say this satisfies the equation. Your answers to the equation are imaginary numbers, where you start to have root of negative numbers. So this is important because if you go back to the quadratic formula, you can actually determine whether your equation is going to have real roots that are real and unequal, which is here, roots that are real and equal, and where there are no real roots, by something that is called the discriminant, right? Now, what is the discriminant? Now, if you remember the quadratic formula, there is this part that is under the square root, b squared minus 4ac. This part of the formula is called the discriminant because we use it to differentiate or to find out whether our quadratic equation has real roots, real and distinct roots, real and repeated roots, or complex roots, imaginary numbers. So you would simply just do b squared minus 4ac, and then whatever the answer is, you check, is it greater than 0, is it equal to 0, or is it less than 0, right? So b squared minus 4ac is known as the discriminant. Now, if b squared minus 4ac is greater than 0, then you would know that your quadratic equation has 2 real roots that are unique, that are distinct, that are unequal. If it was equal to 0, then you would know that your quadratic equation has just 1 real root, so it's repeated the same point 2 times. But if it's less than 0, then you know that your quadratic equation has 2 complex roots, conjugate roots, so imaginary numbers. So there is no point where that curve intersects on the x-axis. And so your answers to those questions, your answer to that quadratic equation is imaginary numbers. So for an example, so this is pretty easy, right? You have the quadratic equation. You just need to find your a, your b, and your c, and do b squared minus 4ac. Whatever your answer is, it should give you an idea of whether your equation is or where your quadratic equation falls in. Now we'll just quickly do it for all of them because all the examples we've done, we've gotten answers that are real answers and they are distinct. So it means that if I were to do the discriminant for all the equations we've done, I should get something that is what greater than 0, because that is the condition for having 2 distinct real roots. My discriminant should be greater than 0. Now, if I go to the first question I solve, b squared minus 4ac. Now, if I were to solve that, my a is 1, my B is minus 5, and my C is 6. Now, B squared is going to be minus 5 squared, which is 25, right? Then minus 4 times 1 times 6. 4 times 6 is 24. 25 minus 24 is 1. That is greater than 0. And so, without solving, it should tell me that the answers to my questions are going to be unequal, they're going to be distinct, and they're going to be real. And of course, that shows because I got 2 real answers that are unequal. What example did we do? So we also did this one, right? So if I were to do the discriminant for this question as well, b squared minus 4ac, b squared is 4 squared, which is 16, minus 4 times 1 times 1, 16 minus 4 is 12. So 12 is greater than 0. And of course, that proves that my answers are going to be real numbers and they are going to be distinct. So I have real numbers here and they are not the same. For the one with the quadratic formula, b squared minus 4ac, which is this part, was 9 plus 16 was 25. And that is greater than 0 as well. So it shows because I have 2 real roots and they are unequal. Now, if I were to have a case where I would do b squared minus 4ac and it was equal to 0, then I would know that the answers I will obtain will be exactly the same, right? Because it just passes on one point. Or if it were less than 0, like the example showed here, then I would know that if I were to solve this, if I solve this equation now, it means that I will not get real numbers because here my discriminant is minus 4, which is less than 0. So probably another assignment is just try and solve this equation. You'll probably get stuck somewhere or you have a hard time figuring it out. But if you use the formula, you probably able to get out something. But this shows you that your answer to this quadratic equation is not going to be a real number. It's going to be complex numbers. And you can get an idea of that ahead of time before you begin to solve, right? So another take-home assignment, try and do this on your own. So the last thing we're going to be looking at today is the relationship between the roots and the coefficients. The roots and coefficients. So you can have the root of the equation and from there be able to get the coefficients. There's a relationship actually. So here we are going to say that let alpha and beta be the roots. Now, I hope you understand what I mean when I say roots. So the roots are the 2 answers you get when you solve a quadratic equation. So there are 2. That's why they are roots, plural. So let alpha and beta be the roots of course, the general form of a quadratic equation, which is ax squared plus bx plus c equals 0. So the relationship is that the sum of the roots, alpha plus beta, is equal to minus b over a, and the product of the roots, alpha beta, is equal to c over a. So if you are given the roots, or if you have the roots of the equation, you can be able to figure out what the coefficient of the quadratic equation is, even without having the quadratic equation itself, and then you can reconstruct it. So for an example, so the first example, if alpha and beta are the roots of this, then what does that tell us? It tells us that the sum of the roots, alpha plus beta, is minus b over a. So minus b is minus 7. So again, pay attention to the sign because the sign is important. So b here is actually minus 7. So if you do minus 7, that's plus 7 over 1, which is 7. And then the product of the roots is c over a, which is 10 over 1, which is 10. Now, let's say the reverse is the case. Let's say you are given the sum and the product of the equation. So they are telling you that alpha plus beta is equal to 5, right? And we are told that the product, that's alpha beta, is equal to 6. And they now ask you to find the quadratic equation. That's very easy actually, because you have this relationship that alpha plus beta is minus b over a and alpha beta is c over a. So if minus b over a is 5, it means that, so first of all, if c over a is 5, if c over a is 6, right? And then we assume a to be 1, right? Then it means that c over 1 is equal to 6 and c is 6. So this is 6. If minus b over a is equal to 5 and we assume a to be 1, it means that minus b is 5. and then b is -5. So we have A, we have B, and we have C. And that is all you need to reconstruct your quadratic equation. And so from there, you can simply deduce that the quadratic equation that has this sum of roots and product of roots is x squared minus 5x plus 6. And it's as simple as that. So that's the relationship you have between the roots and the coefficients of the quadratic equation. So you might be given the coefficients and you might be given the roots and be asked to find the coefficients, or vice versa. But since there's a relationship between them, you can easily do that. So in summary, we've been able to look at the different ways of solving quadratic equations using the three methods: so the method of factorization, the method of completing the square, and the method of the quadratic formula. We've also been able to deduce from using the discriminant to tell us the nature of the roots, whether they are real and unequal, real and repeated, or they are complex roots, imaginary numbers. And we've also shown that the roots of a quadratic equation has or have a direct relationship with the coefficients of the equation, and how you can reconstruct the quadratic equation when you're given the roots, and when you can find the roots when you're given the quadratic equation coefficients. So with that, we come to the end of this week's class. I think we may have a few questions. So yeah, this is the room and time for that. So if you have any questions about what we've gone through this night, we'll use the next 24 minutes to go through them, and then hopefully we will all be on the same page when we are done. So questions?
Hello, sir.
Yeah, I can hear you.
So that means that using that graph, I can tell the roots of an equation using the graph.
Yes. So if you wanted to, you could decide to, okay, you have the quadratic equation. I think you should have some knowledge of how to plot a graph, and then you actually plot out the graph of the quadratic equation and join the points. You would see that. So for this one that we did now, x squared minus 5x plus 6, if you were to plot the graph of this equation, you would see that where that graph intersects the x-axis will be on 2 and on 3. So that shows that those are the solutions to that equation.
Okay,
Yeah.
thank you.
You're welcome. So, I mean, as you're asking these questions, just make sure to actually put in, afterwards, take your time and look at these things. Don't just take my word for it, right? So, if you're asking this question about the graph now, try and see if you plot it, you will actually get what I'm saying. The other examples that I said we should, try them out and see if you're going to arrive at the same answers or how it's going to work out. Because that's how you eventually get used to it, understand the concept, and then you know how to do it whenever you're doing it alone. Yeah, VK, you have your hand up. I don't know if you have a question or you want to say something. You can unmute your mic and talk. Videos. Um, I don't know. I have not referred to any videos. I haven't referred to any videos while on this call. I don't know. Can you see my screen? Because that's what I'm using to give the class. If you can see my screen, then you should be fine. My screen is still visible, right?
Yes, it is.
Okay. So I don't know, Chibike, I don't know what you mean. You can unmute your mic and talk. I don't understand.
No, no, sir. I can't see the screen.
Oh, you can't. Um, I don't know. I think Whitney can see the screen, so it's probably a network issue from your end, because even from my end, it shows that I'm sharing my screen. So I don't really know. But I think there's a recording of these calls. So even if you can't see it now, you can always play back the recording and then be able to follow up back from where you joined the discussion. So yeah, you'll be fine. So I take it that every of the concepts you explained today have been is pretty much very understood and it's clear to everyone. If you have any questions, please ask. Please ask. We have enough time so I can take my time to go through anything that is not clear before we end the call. You have something that you don't understand or you want me to go over it again, feel free to ask your questions and I will do just that.
Is there any
So
way they can set the questions that will be more complex than they are than these examples?
I do not think so. I think we've covered most of the different possible. And so, of course, that's why there are three methods, right? Three methods, right? So if one method isn't working for an equation, then you know that you have to use another method, right? So it goes back to my earlier point: solve as many examples as possible. Solve as many examples as possible.
Is it
So you see the different ways it comes, different patterns it can follow, and then you get used to it. But I think we covered all the basics. So there's no question now that will come that will go outside the fundamental things that you've heard in this class. You always be okay, factorize or completing the square or use the formula, something. But of course, you have to solve as many as possible so that you just get used to it. You wanted to say something?
Yes, is like in exam situation now, is there a way to tell that by looking at the question, you just know that this is the formula to use, so we don't end up wasting time?
So So, like I said, the factorization method is the easiest. So, if you want to solve a quadratic equation, first thing you should do is check, can factorization work here? Because if it can, then it is the easiest method to follow, right? So, like, if you notice when I saw this other question, the quadratic formula, I was looking at it and I was like, okay, we can actually do factorization here, right? So, if I give me this question, I will not start using the formula because it's going to be longer. So, simply, I would say, okay, 2 times minus 2 is minus 4. Do I have two numbers, two factors of minus 4, that if I add them, they'll give me 3? And yes, I do actually, because I saw that this could be known factorization. And those two numbers are 4 and minus 1. Because 4 times minus 1 gives me minus 4, and 4 plus minus 1 gives me 3. So I can simply just come and replace this 3 with 4x minus 1x, which is minus x minus 2. So this is squared. And then I group it like before and factorize, and then I get my answer, right? So factorization is the easiest method to use. So always check that can this equation be factorized before you go ahead with any. So then if you can't, then you now decide, okay, do I do completing the square or do I use formula? And either of them should now work. So like I said, so for this particular example, try using the other method. So you see, okay, this one took me this long to do, this one took me this long to do. I think I prefer this, I don't like this. And then with time, it becomes natural, it becomes very intuitive. That you just, by looking at it, if you can tell, right? So, okay, I can factorize, I can't factorize. So it's just doing it as many times as possible. It makes it easier. Practice, practice, practice makes perfect. This. So yeah. So Chibiki, I don't think a summary is going to do you good if you miss the starting, because I explained a lot of the key concepts at the beginning. But like I said, there is a recording. I can see that this call is being recorded, and I think the organizers are going to upload it to some platform eventually. So you can always go and rewatch and then follow from the beginning, because if I give you a summary now, it may not really do you much good. It may not be of value. So my advice would just be to rewatch the whole recorded call from the beginning and then follow it step by step. There were some questions in the middle as well that I answered, so they may also give you some clarification, because I will not start referring to, oh, Whitney asked the question here. So when you rewatch it, you would, it will give you more insight than if you were to just run through it now and from the beginning, you get. So I don't know if I think you guys are always giving access to the recording. So yeah, you can always just look at it, and then if you then have any follow-up questions, then we will now see from there. So, okay, does anyone want to say something? Yeah, Chibuike, no problem. You're welcome. So I don't know if there are any more comments or questions or observations from anyone. If we do not have any, I think we will draw the curtains at this point. So yeah, I think this is one of our more engaging classes so far, and I would like this to continue, because I mean it's good when I get feedback and then I know what I need to explain more and what I need to, go into details about. So I think this is wonderful. So try as much as possible to always come from the beginning, engage in the classes, ask your questions. Of course, there's a time for questions at the end, but if there's something that is going on that you clearly don't understand, you can always feel free to ask your questions, and then it makes the class more engaging. I mean, it's math, so there needs to be that feedback in order to, have a grasp of what's going on. So today's class was wonderful. I thank all that showed up for it, especially the ones that joined from the beginning, the ones that came in the middle, the ones that come in at the end. Gracias. Thank you all very much. And yeah, we'll see again next week for week 4 of the math class. So thank you all for coming, and yeah, good night.